When you think about NASA and space, you probably picture rockets, astronauts, and amazing views of Earth. But behind every beautiful photo from space, there's a long list of things that can go horribly wrong. And some of those dangers scare NASA more than anything else. So, what is NASA actually most afraid of in space? Let's start with something invisible, silent, and deadly: radiation. Space is flooded with high-energy particles from the sun and from outside our solar system. On Earth, our atmosphere and magnetic field shield us from most of it. In deep space, astronauts are exposed almost directly. This kind of radiation can damage DNA, raise the risk of cancer, harm the brain, and even interfere with electronics. For short missions, like trips to the moon, that risk is manageable. But for a long trip to Mars, astronauts would be exposed for months, even years. A single powerful solar storm could hit them with a burst of radiation far beyond what's safe. NASA watches the sun constantly because one bad event at the wrong time could be disastrous. So, yes, NASA is afraid of radiation. But that's not all. Another top fear is something you might not notice until it's too late: tiny pieces of space junk. Orbiting Earth right now are thousands of dead satellites, fragments from old rocket stages, and even flakes of paint. These objects may be small, but they move at incredible speeds. Even a bolt the size of your thumb can hit with the force of a bomb. The International Space Station regularly fires its engines to dodge known debris. Astronauts have found impact pits on windows and handrails. Now imagine a fast-moving shard of metal slamming into a spacesuit or punching through a spacecraft hull. That's the nightmare. NASA tracks as much debris as possible with radar and telescopes, but there's a limit to what they can see. Below a certain size, objects become almost impossible to track, yet they still have enough energy to be deadly. It's like driving through a hailstorm, where each hailstone is a bullet. But the danger doesn't only come from human-made junk. Space itself throws rocks at us. Micrometeoroids are tiny bits of natural rock and dust left over from comets and asteroids. They zip through space faster than a bullet. Spacecraft and suits are designed with multiple layers to handle small impacts, but if a slightly larger piece hits the wrong spot, it can pierce right through. NASA worries about this because it's one of the few things you can't really predict perfectly. You can design armor, you can test materials, but in the end, you're always rolling the dice a little bit. Still, maybe the thing NASA fears most is not outside the spacecraft, but inside it. In space, your spaceship is your world. It holds your air, water, heat, power, and communication with Earth. Anything that causes a loss of those life support systems becomes an emergency. Take fire, for example. On Earth, hot air rises, flames reach upward, and smoke goes to the ceiling. In microgravity, fire behaves differently. Flames become more like glowing spheres. Smoke doesn't drift away on its own. It can spread in unexpected ways. A small fire in a closed spacecraft, filled with electronics and plastic, can turn into a toxic, deadly situation very fast. Then there are leaks. If a micrometeoroid or piece of debris punctures the hull, air starts escaping into the vacuum. Sometimes it's obvious. Sometimes it's a tiny, slow leak that shows up as a slight pressure drop over hours or days. Astronauts train to find and patch leaks quickly, because if you lose too much air, you don't get a second chance. There's also the risk of systems failure: a pump that stops working, a clogged filter, a broken valve. On Earth, you call a repair team. In orbit, the astronauts are the repair team, and the tools they have are all they're going to get. That's why NASA spends years testing hardware, building backups, and rehearsing what-if scenarios. But danger in space is not just about hardware. It's also about people. NASA is deeply concerned about the human body and mind in space. Microgravity causes muscles to shrink and bones to weaken. Fluids shift toward the head, which can affect vision. Over months, astronauts can develop vision problems that may not fully go away. The heart doesn't have to work as hard, and it can change shape. Even the immune system can act differently. Now imagine dealing with all of that on a long-duration mission to Mars. You're months from home. You can't just turn around and come back. You're isolated from family and friends, confined with the same small crew in a tight space, with delayed communication to Earth. That leads to another major fear: psychological stress. NASA worries about how people cope with isolation, confinement, and constant risk. Mood changes, sleep problems, irritability, and conflict between crew members can all threaten a mission. Even highly trained, carefully selected astronauts are still human. A serious mental health crisis in deep space would be incredibly hard to manage. That's why NASA invests heavily in crew selection, training, and support. They simulate isolation in Antarctic bases and underwater habitats. They study how teams work under pressure. The goal is not just to pick strong individuals, but to build resilient crews. And there's one more category of fear that sits in the back of NASA's mind: the unknowns. Space exploration constantly pushes into new environments, and with that comes risk that you can't fully predict. When NASA landed the first rovers on Mars, they worried about dust clogging joints and covering solar panels. When they send humans back to the moon, they have to consider abrasive lunar dust that sticks to everything and can damage equipment and lungs. Every new destination has surprises: strange chemistry, unexpected temperatures, unusual magnetic fields, hidden pockets of gas under the surface. The unknowns are not just mysterious. They can be dangerous. And then there's the big picture fear: a catastrophic failure that kills a crew and threatens public support for human spaceflight. NASA remembers every accident: the Apollo 1 fire, the Challenger and Columbia shuttle disasters. Each tragedy reshaped the way NASA thinks about risk. Behind the scenes, there's a constant tension between the drive to explore and the responsibility to protect human life. So when you ask, what is NASA most afraid of in space? The answer isn't just one thing. They fear radiation that can slowly damage bodies and electronics. They fear tiny, fast-moving debris that can rip through metal. They fear fire and leaks, which can turn a safe spacecraft into a death trap. They fear long-term harm to astronauts' bodies and minds. And they fear the unknowns that hide in every new mission. But here's the important part. NASA's job is not to eliminate fear. It's to understand it. Every fear becomes a research question. Every risk turns into a checklist, a test, a new design. They build better shielding. They track more debris. They improve suits, tools, and training. They study the human body and mind in more detail. They learn from every mistake, every close call, and every mission. Fear, for NASA, is not a reason to stay home. It's the reason they prepare so obsessively before they go. So the next time you see a rocket lifting off, remember this: it's not just a triumph of technology. It's a sign that, despite very real dangers, we're still willing to face the worst that space can throw at us, just to see what's out there. Because in the end, NASA isn't just afraid of what could go wrong in space. They're also afraid of what we'd miss if we never dared to leave Earth at all.